Sufficiency and Critical Reasoning. My name is Dave Green, and before we get started, I'd like to know you guys can hear me okay. So if any of you could just verify for me in the chat on the right that you guys can hear me, that'll be great, and then we can get started with this webinar. So thank you. Yes, great, fantastic. So nice to meet you guys. My name is Dave Green. As I mentioned, I am a senior tutor here at examPAL. And today, in the next hour or so, we're going to talk about two of the most confusing topics there are on the exam, BS and CR. And the reason that we chose to combine these two into one webinar is that besides being hard, we believe these topics have one other thing in common, which is that they both can be improved pretty quickly once we know how to do that. Okay, there's a secret sauce, if you will, of these topics, and that's what we're here to talk about. So before we dive in, I want to give you guys a brief introduction into who we are, and what we do at examPAL. So just a few minutes on that, and then we'll start talking about the topic. So if you've signed up with us, which you have, probably if you're accessing this, that means you automatically have full access to examPAL's video lessons, and you probably already know our team is there to answer any questions you may have. So this is me, by the way. So what is examPAL? Well, we started examPAL as GMAT teachers who understand that students all around the globe are currently paying too much and they're doing it for the wrong product. And they only realize that they're doing this after they complete their preparation, which means when it's too late. So what do we think students are missing? Well, you know that feeling when someone explains something to you and you just don't get it? We all know that feeling, right? So imagine what it's like to prepare for admission tests such as the GMAT, the GRE, or the SATs. The questions in these tests can have up to 10 different possible solution strategies. And all you need to do is find the one fastest one. And the thing is that students all over the world are bombarded with thousands of practice questions, tips, tricks, and shticks, and they're all there to help everyone in the same way. But there's no such thing as the explanation. I've personally taught lots of students from all over the globe over the years. And when a novice teacher comes to me and asks, how do you explain this question? My answer is, to whom? To whom do I explain it? So that answer is really examPAL in a nutshell. To whom? We don't just explain what makes the correct answer correct, but we first ask ourselves, who are you? So we do three things that no one else does. First thing, we study the way you think as a student, as a user. Secondly, we study the effectiveness of all the different possible solution strategies. So your goal on the test is to not only be correct, but also to be fast. And if there's a faster way to solve a question correctly, our goal is to find it. And third, using this information, we find the fastest and best way to solve each question, as I just said. So, and by the best, I mean the best for you. Okay, and this is something that not even private tutors can really do. We're there with you in each and every question, from basics to the hardest ones, and when we offer you a solution strategy, we don't guess it works. We actually measure everything. So just to summarize the pain that a lot of test takers feel. So test takers spend a lot of time and money preparing for admission tests, only to realize that the brick and mortar physical courses that they take are, first of all, frustrating, since there can be lots of different ways to solve each question, and how you find the one that's right for you. They can be ineffective, because your biggest enemy in these tests is time, and how can a one-size-fits-all course tell you which is the most effective way for you to save time? And they can finally be time-consuming, okay? You're wasting too much time on thousands of questions and tips that aren't relevant to you specifically. Some of them are too hard, some of them are too easy. They're not suited for you. And shouldn't you focus only on what you need? Okay? And aside from all these things, there's a far greater revolution happening here, which is in the understanding of what preparing for these exams even means. Because these tests, all these prep tests, are unlike the tests you had in high school. Okay, mastering admission tests isn't about knowledge, but rather it tests a skill, which we call cognitive flexibility, which means your ability to change your set of tools very quickly according to the changes in the data that you're getting. And this is why the test has harsh time constraints, and we can keep moving from algebra to geometry to word problems very quickly. So we don't just provide you with the knowledge you need for the test, we train you to find the fastest way to solve each question. So how do we do that? Real quick, our process starts with interactive video lessons. While you study our course studies you, and it's fun. So each topic starts with a short video teaser, and then an introduction that gives you all the basic tools that you need, whether it's formulas or the logic behind a new concept. And from there we move to the lesson, in which we demonstrate how different questions from the test can be solved using different approaches. Next, we get to our special sauce, if you will, practice. So each practice session starts with a diagnostic phase. And we found that even when there are 5 or 6 or even more ways to solve a question, we can divide all of them into 3 strategies, which we call precise, alternative, and logical. This is the PAL in examPAL. In the diagnostic phase, we analyze how well you're using each of these 3 of the PAL. So this question, for example, can be solved logically by figuring out the ratio between the numerator and the denominator, precisely by simplifying the algebraic expression, or alternatively by using simple numbers, right? And only one answer can be correct. So in the diagnostic phase, we quickly learn what your level is in implementing each of these tools. And then comes the improvement phase, in which we focus on your level and find the best questions for you to solve in order to improve your schools, which means not just being adaptive, the way the test is, right? Not just giving you easier or harder questions, but finding exactly which tools work best for you and what reasons there are for your mistakes. And then comes, this was the improvement phase. And then comes the best part, the optimization phase, in which both practice questions and solution strategies are chosen to match your own personal needs. In this example, for what we see on the screen, the system has found 4 solution strategies ranked in order of relevance to you. So in professional terms, this is what's called in the industry a semi-supervised recommendation system. What that means, in other words, is that we're moving from machine learning to machine teaching, from deep learning to deep teaching. We're scanning through the ideas of others in order to find the one idea that's the easiest for you to understand and implement. And we do all this using data from our over 50,000 students from over 156 countries who help us teach you. Okay, our students teach us how to teach them, and it works. Okay, the effect is amazing. Our research shows that an average user using examPAL reaches his highest possible level with these segments of just 30 questions per topic. We've gotten a bunch of global awards and recognition for education, innovation, and AI, and our students are very happy. Just take a look. So last but not least, we give you a real success guarantee. 70 points in the GMAT and up to 7 points in our GRE course. And I'm saying real because we're not one of these places where improvement is measured relative to a mock test you've done when you had no clue about anything. if you have a previous official score you're not satisfied with, we guarantee you're going to improve it significantly. Okay, so bottom line, that's who we are, and this is a chance, well, your last chance to hop onto our Christmas sale, which is 30% off of any and all of our courses, only for the next 48 hours. So go to examPAL.com to take us up on it. So that was who we are. And now I want to get back and start talking about data sufficiency and critical reasoning. So I know a few of us have joined, so if someone could just give me a reality check that you guys can hear me okay in the chat again, that would be great. And I'm going to start talking about data sufficiency, which is the first topic we're going to talk about today. So, can you guys hear me all right? I'd like you to tell me. Meanwhile, though, we're going to conduct a poll. So, you guys can hear me? Fantastic. So, to start off, tell me, what do you think is the most common mistake in data sufficiency questions? So you should be seeing a poll on the screen. Do you guys see it? No, sorry. Having a technical issue with the poll. All right, never mind the poll itself. Let me just ask you guys out loud. What do you guys think is the most common mistake in data sufficiency questions? Do you think it's guessing? Do you think it's not looking at each of the statements separately? Do you think it's data overload? Do you think it's overthinking all the possible options? Which one of those do you think it is? Maybe you guys want to tell me in the chat. If you not looking at each statement separately, I can't see your name for some reason, but okay. And someone else is saying overthinking, and someone else is saying mutually exclusively. Overthinking. Another vote for overthinking. Interesting. Okay, so not looking. Okay, so we have 2 votes, if I'm counting correctly, for not looking, and 2 votes for overthinking. So first of all of these need to know when to stop, i.e. overthinking. And so another vote for overthinking, another vote for not looking what the question is asking. Or no, that's a different one. Not looking what the question is asking is different than not looking at each of the statements separately. So first of all, you're all right. Okay, no one is wrong here. All of these are indeed possible reasons for mistakes, and if you feel that it's a reason for you for a mistake, then it's a reason for you for a mistake, and we need to work on solving it. However, the #1 reason, the one I was shooting for based on the data we have from our thousands of students, is not looking at each of the statements separately. Okay, and together we're going to see when and why this usually happens. So let's start talking about the 5 keys to perfect data sufficiency. So first of all, let's discuss in general, what is it that makes DS so difficult for so many of us? Well, a main reason that it's quite difficult for us is that it requires us to use abstract concepts, right? It asks us not to solve questions, which is what we've been trained and maybe are even hardwired to do, but to use logic to determine whether questions can be solved theoretically. And this is not at all the way we're used to thinking on exams. So a necessary condition for being able to think in an abstract way is to first pay attention to small details. Say we're asked if X answers some criteria using statement 1, and we've seen that it indeed does for lots of different values, 1, 3, 7, 42, and so on. So we want to rule out B, C, and E, right? But wait, hold on. Are we sure that this holds for all cases of X, or is it just for some case of X? So Were we told in the stem that x is positive? If not, what about 0? What about negative numbers? Were we told if x is an integer? If not, what about fractions that are smaller than 1? We have to first pay close attention to the small details in the question stem in order to properly know what it is we're being asked. Okay? Sorry about that. And oftentimes also, this is actually the biggest reason that DS questions are hard, is that there are confusing answer options. Even after you get the abstract concepts and you remember to notice all the little details, these questions are still designed to trip you up. And that's really what we're going to talk about in the next half hour. For the next half hour, a little bit less, we're going to talk about DS, and then in the final half, we're going to talk about critical reasoning. So the solution to this problem of getting confused is really pretty simple. This is how we're supposed to solve data sufficiency questions. First, we check whether the question is solvable with statement 1 on its own. Then we do the same thing with statement 2 on its own. And then only if the statement wasn't solvable with the first 2 statements do we try combining statements 1 and 2. So that's really it. If you're going to remember one thing from this webinar, remember this slide, okay? If you stick to this simple rule of thumb, really you should be fine. So what we're going to do now together is look at examples of data sufficiency questions and review 5 keys that are sort of derived from this pretty simple system we have up here. So let's just hop in. So the first key we call ace the A's. So here's our first question. And before we begin, just a quick reminder of what the answer choices in data sufficiency mean. So don't even look at the question now or the statements, just look at the answer choices, A, B, combined, all that. So the text you see on screen next to the letters is really just a simple way to remember what each answer stands for. Okay, so A means the first statement, and only the first statement is sufficient to answer the question. B, the second statement and only the second statement is sufficient to answer the question. C stands for combined. Combining the 2 statements and only combining them gives us sufficient information. D, divided. Okay, each statement on its own gives us sufficient information to solve the question. And E, impossible. Okay, doesn't quite stand for it, but still, that's it can help you remember it. E, impossible. If anyone has a better suggestion, he's welcome to bring it up. Anyway, so impossible, the data is insufficient to solve the question, even when it's combined. Okay, and remember, there's no point, and no point will be expected, nor should we actually answer the question. We really merely have to figure out if solving it is possible with the provided information. In fact, we found that in cases where the questions were solved using the precise approach, which is actually doing the math, students were 26% slower and 19% more likely to get a wrong answer compared to those who used the logical approach. Okay, so now let's actually try and solve this question. And first of all, let me ask you guys, we're going to do another impromptu poll. Which accessory do you think would be most useful to help solve this question? So I'm going to give you guys the options now. Is it a masking tape, the masking tape to block out parts of the screen? Is it a calculator? Is it colorful pens? Is it a multiplication table? Or is it a stopwatch? Which of these would you find most useful to answer this question? Let me see what you guys think. Masking tape, Nitin. Interesting. Why would masking tape help you? I wonder. Table, multiplication table. There's a vote for multiplication table. Masking tape, another vote for masking tape. Okay, cool. All right, so since helping to others hide statements. Okay, great. So that was what I was going for. So of course, if any of you want any of the other Accessories, that's fine too, but I was going for masking tape, okay? And the reason being, well, Nitin already told us the reason, but let's explain why this reason is relevant by actually solving the question. So first of all, we can approach this question using a logical approach, which is generally the strategy we use, since data sufficiency questions are by their nature logical questions. So let's start by looking at statement 1. Okay, B is smaller than 8 and larger than 0. Okay, so first of all, knowing that B is larger than A is positive. Knowing B is positive, sorry, tells us that A must be positive as well. Okay, since positive times positive equals positive, referring to A times B equals 64. And second, when we get ranges, it's often useful to use an extreme. So let's pretend B equals 8. If that's the case, A will also be 8, right? So, but B isn't 8. B is less than 8, which means logically A has to be larger. And that's our solution, okay? So statement 1 is sufficient, and meaning we can go ahead and cross out A, B, sorry, not A, we can cross out B, C, and E, okay? Which I just did. So now let's look at statement 2, okay? A squared is larger than 64. Well, since we know that A has to be positive, this means A has to be larger than 8, right? Well, wait, I just tricked you. I don't know if I actually tricked you, but what I just said wasn't correct. We don't know that A is positive. This was knowledge we got from statement 1, but we have to put aside that knowledge now. Looking at statement 2 on its own, A could be a -9 just as much as it could be a +9. Okay, and therefore statement 2 is actually insufficient, and we should eliminate answer choice D, and there we have it. A is our answer. So the point of this is that when statement 1 is enough, we should never add it to statement 2. We have to look at them on their own. And a common mistake that students make is remembering the information given in the first statement and using it, whether consciously or unconsciously, when checking statement 2. So don't fall for this. We have to read and solve the 2 statements separately. And this is why something to block your screen would be a good accessory to have here. And we may not have masking tape in the test, but if you need to, you can physically block the screen with your hands or the scratch pad you have. Or you can write down both statements on your scratch pad and just cross out number 1 after you use it. So whatever it takes, but you can do it. Okay, let's move on to our second key. Be yourself, or as I like to call it actually, be by itself. You'll see why. So let's look at this question. If x is an integer, is x plus 1 over x an integer? So let's look at statement 1 as we tend to do. So 2 over x is an integer. So this means that x could be 1 or 2 or -2, right? Not enough information to pick between them. So we're going to check off A and check off D, right? So now let's look at statement 2. X is a positive even integer. So we can immediately see that combining this with statement 1 gives us the answer. 1 and 2 and -2, sorry, are ruled out, and x must be 2. So the answer is C, right? Wrong. Remember, we first have to check statement 2 on its own, okay? And the logic behind statement 2, and remember, we're looking for logic usually in DS, is that if x is even, then x plus 1 is definitely going to be odd. So x plus 1 over x is odd over even. And that can't be an integer, which answers our question. So 2 is sufficient to answer on its own, okay? And the answer choice is B. And indeed, when we looked at students who answered this question, it's taken those who use the logical approach, it's taken them an average of 1 minute and 5 seconds, and those who use the alternative approach of using numbers to eliminate contradictory answers, just 8 more seconds. So in this case, our system is going to choose which one's faster for you, mainly according to your personal inclination, since the time difference is quite small between them. So the second key that derives from this is when statement 1 isn't enough, we shouldn't add it to 2 right away, right? The first question showed us a case where 1 was enough and 2 wasn't, and this question showed us the opposite, right? Where 1 wasn't enough and 2 was. But what's common in both these cases is that we have to remember, check both statements on their own before even thinking about combining them, all right? So let's go on to the third key, see the full picture. Okay, in rhombus QRST above, what is the length of QS? Not drawn. By the way, I should have said this earlier. I am going to move through these questions kind of quickly because really our goal here is not for you to necessarily solve them right now. I just want to, I'm using them to show you, to make a point. So don't worry if you don't have time to actually solve them. If you feel I'm moving a bit fast, that's fine. I just focus on the point I'm making, and later you guys will get access to this whole webinar and all the slides, and you'll be able to solve them at your leisure. So, moving back to this question deals with a rhombus. So let's quickly remind ourselves of the material, right? Rhombus area equals product of diagonals divided by 2, which equals side times height. And in this figure, this translates to QS times RT divided by 2 equals QT times PR. So statement 1 gives us PR, and statement 2 has QT. But there's still 2 variables left. And it's obvious that neither 1 nor 2 is sufficient to answer on its own. So we can go ahead and eliminate A and B and D. But I mean, that's definitely true, but it seems that even when combining them, we're still short, right? Well, hold on a second. Let's take a deeper look here. Another characteristic of a rhombus is that all sides are equal, okay? So this means that QR equals 15 as well. And now we have 2 sides of a right triangle, that is QRP, and using the Pythagorean theorem, we can get QP, okay? If we have QP, and remember, we don't actually have to calculate QP, we just have to know that we have sufficient data in order to be able to get QP. So if we have QP, which we will, and that means we have PT, and then drawing RT, we can see that we have another right triangle where we know both sides, PRT. And this time we can figure out RT, okay? RT is what we needed to solve our equation. So our answer is C, all right? So this was quite a difficult question, and again, you can go over it later if you need, but the point it exemplifies is true in many cases, and that's our third key. Combining 1 and 2 may add more information than what we see, okay? In other words, checking 1 and 2 separately might not be enough to give us intuition as to whether combining them will give us the answer. We might have to we should always re-examine the question with the combined info and see what we can do, since often the whole is greater than the sum of its parts. And this is especially true in geometry. The reason being that there's a lot of external logic going on. So the combination of the statements leads us to new information, which leads us to new conclusions. Now this logical solution, which I just showed you guys, is actually quite long. It took students an average of 2 minutes 40 to solve the question correctly. But hold tight. This is the solution, logical solution, which 88% of the students who answered used correctly. Okay, and only 3% of the ones who answered correctly used the alternative approach of using numbers, and just 9% used precise calculations. Most of those who tried the precise approach actually got it wrong or spent over 3 minutes, which is almost as bad as getting it wrong. So our system will probably advise you here, based on the wisdom of the crowd, to use the logical approach. And I would take that advice if I were you. On to our fourth key, D for divide. All right, let's look at the next question. What is the volume of a rectangular solid? So this question here is about the volume of a rectangular solid, so let's remind ourselves what the formula for this is. Rectangular solid volume equals A times B times C, right? A and B being the size and C being the height. So looking at the answers, well, statement 1 gives us all 3, right? It gives us A, B, and C. So it's definitely enough. We can go ahead and check out B, C, and E. So now let's look at statement 2. So it gives us not the length of the sides, but the areas of the faces, right? And since a face's area equals the product of its sides, we can create 3 equations. A times B equals 8, B times C equals 14, and A times C equals 28. Now you might have noticed that the dimensions mentioned in statement 1 actually give us a solution to these equations. 8 equals 2 times 4, 14 equals 2 times 7, and 28 equals 4 times 7. Okay, and if we know the dimensions, we can, of course, go ahead and calculate the area. So if we have no new information that we didn't already get in statement 1, does this mean statement 1 is the answer, that A is the answer? So no, the answer is no. It doesn't matter that statement 2 doesn't add information. We have to look at statement 2 independently. And if we do that, we see that statement 2 gives us on its own 3 equations with 3 variables, which is enough for an answer always and on its own, even without statement 1 revealing to us what the answers are. Okay, so, and for that reason, the answer here is divided. Each statement on its own gives us enough information to solve the question. And the key that's exemplified here is that when statement 1 is enough, if statement 2 repeats it, that means statement 2 is also enough. And it's not unnecessary. And this is even true if it repeats it in a longer, more long-winded, more wordy way, or a way that makes us work harder. But if in the end of the day it gives us the same amount of information, that means it's sufficient. So don't get tricked into thinking it has to have new information. Okay? Great. So let's move on to our 5th and final key in data sufficiency before we move on to critical reasoning. So the 5th key is simply simplify the unsimple. All right. So this is a bit wordy, but we're going to get through it. $15,000 was invested for 1 year in 2 different funds. A third of the amount in Fund A, which earned K% simple annual interest, and the rest in Fund B, which earned M% simple annual interest. What was the total interest earned that year? So let's change it up here. Let's do another kind of impromptu poll. So what do you guys think is the main reason that people got this question wrong? Was it A, they forgot to check the statements on their own? Was it B, they did not understand the question? Was it C, they didn't convert the information into its most simple form? Was it D, a calculation error, or was it E, they did not attend an examPAL webinar? So just to go over those quickly, did they forget to check the statements on their own? Did they not understand the question? Did they not convert the information to its most uncomplicated form? Did they make a calculation error or miss a webinar? So Nitin thinks that they didn't convert the information, And I see here 2 other votes for statement 2. They just didn't understand the question. Sorry, didn't think it's unable to simplify. Yeah, they didn't simplify into its most uncomplicated form. Okay, so for those of you, no one's, I see another vote here for C, which is didn't convert. Okay, great. So I was going for C, but that is the most common reason you're not simplifying. And allow me to explain why this is such a big reason here. So as we've mentioned, DS questions are, first of all, logical questions, right? Sometimes we'll use alternative solutions, though, such as plugging in numbers in order to eliminate contradictory answers. And when do we use a precise answer strategy, right? When can we simplify the information further than how it's presented? That's when. When the question is presented in a complicated, wordy way, such as here, and it can be simplified, that's when a precise answer strategy is called for. So let me show you what I mean. So statement 1 gives us the relation between K, the interest percentage of fund A, and M, the interest percentage of fund B. So we can turn that into K equals 1.5 M plus 1, which is one equation with 2 variables, not enough to solve. We can go ahead and rule out answer choices A and D. Okay, how about statement 2? So 2 is another equation with M and K. Not enough. We can rule out B as well. Okay, so now let's combine 1 and 2, and that's going to give us 2 equations with 2 variables, which is enough to solve. So answer choice C, right? Or is it? By now you should be suspicious of when I say that something is the answer. So probably that wasn't so surprising, but let's talk about why it's actually not C. So we do have 2 equations here, but we have to check, do we have 2 different equations? Right? Fractions can be confusing, and thus we should simplify them into integers. So if we multiply K equals 1.5 M times 2, we get 2K equals 3M plus 2. But look at that. That's exactly the same equation as we have in statement 2. Meaning, both statements, that is, give us the same equation. And that means that combining them doesn't give us any new information. Combining them, we still have 1 equation with 2 variables. We don't have 2 equations because we just have the same equation twice. So we have 1 equation, 2 variables, can't be solved, answer choice E. And this portrayed our 5th key. When 1 is not enough and 2 repeats it, the answer is E, impossible. Both this question and the last question before had statements 1 and 2 providing the same information, disguised as being different information. In the last question, the information was sufficient in both of the cases, and here it wasn't sufficient in any of the cases. The point, though, is the same. We have to make sure and check whether the information we're given is indeed new information, or is it just a differently phrased repetition. So to summarize this part of the webinar, as I said in the beginning, first we solve 1, then 2 on their own, and then only if necessary do we combine them. And that's really it. That's what it all comes down to. Treating the statements on their own is so crucial, and so many people confuse this simple point. It's worth thinking about how to avoid this. My personal preference is I tend to copy the first statement down, solve, and then cross it out and write down the second statement only so I can focus on it alone. And some people physically hide part of the screen with their marker. If that works for you, go for it, whatever works. So this concludes the first part of our session. I hope it helps. Hope you guys, although you guys tell me if it did. But let's move on to tackle another topic many people find really tricky, critical reasoning. So the main issue in the verbal section as a whole is that there's never enough time. Okay, we have all these questions, more than we have in quant, and they're a lot more demanding. longer text, lots of details, convincing wrong answers. So as we're going to see, the issue of time can be solved by avoiding the verbal time traps. That is. As they say, right, longer text, as I said. As they say about verbal time traps, a clever person solves a problem, a smart person avoids it, and saves lots of time and avoids stupid mistakes. So here, as before, we're going to go over all 5 keys. Sorry. So the first key we call the although argument. And this is actually the toughest argument for most students, but once you master it, you can really solve some of the toughest questions. So let's get started with a question taken from our Intro to Critical Reasoning section. Sorry. So which of the following, if true, does not strengthen the argument that control over fire, is the reason for earlier humans' extended lifespan, which does not extend the argument? Okay, so don't even go read all the answers, because we're not going to do that here. Rather, we're just gonna focus on D here. Okay. So, and the most common mistake comes from misunderstanding answer choice D. So let's look at it. In the century after the discovery of fire, a plague killed 20% of the early human population. So the argument says fire is good for human life, and this is telling us actually in the period after fire was introduced, something very bad happened to human life. So this weakens the argument, making C our answer, right? Well, hold on a second. We already know that human life did increase. The question assumes that this is the case by asking us what's the reason for life increasing. Okay, so the question is whether fire helped or didn't help. And what's being pointed here is that this increase happened even though a different factor other than fire, this plague, caused an opposite effect. So the although argument here actually strengthens the argument. Although something negative happened, fire was enough of a positive factor that it overcame it, and still it caused an overall positive effect. Okay, although average lifespan was supposed to be shorter, actually it was longer. Fire made it longer. You can think about what's happening here as kind of a race. Okay, certainly if we see one guy beat another guy to the finish line, we'll think that he's faster. But imagine that we see the whole race and we see that the second guy actually got a head start of 100 feet. So now we know for sure that the first guy is actually much faster. And this is really our first key. If, although something negative occurred, we still get the outcome, this strengthens the claim that the cause contributed to this outcome. And this is what's happening in although arguments. If we know the result of a process, the presence of another factor pushing in the opposite direction actually strengthens the case for the factor we're focusing on pushing in the right direction. So this was solved using precise. And our data shows that in this question, students who used alternative approach actually took, on average, 30 seconds longer, which is a lot. So keep that in mind. We don't want to use the alternative approach of actually checking all the answers and comparing them in the verbal section. We want to avoid that as much as we can. So let's move on to our second key. Outer knowledge, inner wisdom. Here we're going to talk about logic, and about knowing which kind of logic to look for can save us time. So let's see. Many new office buildings have emerged in Saint Martin, virtually doubling the available office space. The city is expected to maintain its population and does not currently have any shortage of office space. Nevertheless, investors have almost tripled the amount they were willing to pay for any available office space or any future office building projects in the city. Which of the following, if true, most justifies the investors' willingness to pay more for office space in Saint Martin? Okay, guys, time for another quick poll. not what the answer is, but rather I want you guys to think, what do you think this question primarily revolves around? Is it A, the concept of causality? Is it B, the logic behind pricing? Is it C, the structure of the passage? Is it D, evaluation of the different answer choices? Or is it E, spotting contradictions? I'll say that again quickly. A, concept of causality. B, logic of pricing. C, structure of the passage. D, evaluation of different answer choices. And E, spotting contradictions. What do you guys think this question is about? I see a vote here for C, the structure of the passage. I see a vote for E, spotting contradictions. Okay, interesting. So, actually, interesting that those are the ones you guys marked. So I actually meant, I see another vote here for A, concept of causality. So A is definitely, I mean, that's fine because causality is, of course, involved here. I'll accept that answer. But I actually meant B, which none of you guys said, the logic behind pricing. So allow me to explain. I'll state the obvious first. The GMAT is an admission exam to business school. And what this means is that very often the GMAT is looking to see if we understand business reasoning in verbal questions. So now let's look at this approach. Let's approach this question from a business point of view. What could justify the investor's willingness to spend more on this product, office space? So using the logic of pricing, we're going to see that they must be expecting to make a higher profit off of each unit of the product. But how? Well, using the same logic, we can see that there are really only two options, either lower cost or higher revenue. And since the passage tells us that their costs are actually higher, 3 times as much, we know we're looking for an answer choice, which gives us a reason that they can expect higher revenue. And that's exactly what C does, right? And it tells us that they can afford higher rental rates, meaning that it's a higher revenue. So the point here is that we could figure out almost exactly what we're looking for without needing to go through the answers, okay, just by using the logic of pricing, right? And this is an important point, okay? Because not only is reading all the answers really, really time consuming, but it's also can also be misleading. It's like meeting 5 people who tell you a story and you know 4 of them are lying, but you don't know which. And they're all trained actors. They're really, really good, and they're so persuasive, and we don't want to listen to them. We're much better off figuring out exactly what we're looking for before we let them speak, and that way we won't be fooled. So many questions can be solved using either the logic of pricing, the logic of range, or the logic of averages. All right. And more generally, we also need to use the logic of argument structure, which isn't business reasoning per se, but is another form of logic we should use. So the second key is when a question deals with issues such as pricing, range, average, or argument structure, we should use our logic before using the answers. And this question showed us what a logical critical reasoning question looks like. We need to use external business logic, which doesn't appear in the question. In our course, you're going to be exposed to all the kinds of business logic the test expects you to know. On to the third key. Don't look for an answer, answer. So here we're going to talk about precise solutions, how we can use just the data in the question stem without using external knowledge to solve the question. So let's look at the question. With continuously growing populations, developing countries are purchasing many genetically modified plants whose yields are substantially higher than those of regular plants. However, GNC opponents claim that since the consequences of such vast use are not clear yet, these countries' governments must avoid the use of GNC plants at this time, which of the following, if true, most weakens the claim of the GNC opponents. I'm not going to go to the answers now. So the first thing to notice is what exactly we're being asked here to weaken. The claim of the G and C opponents, right? So there are two rival claims here, and let's identify the basis of each of them, the opponent's claim and the supporter's claim. So the claim supporting G and C isn't stated explicitly, but the word with in the phrase with continuously growing populations serves to imply that this is a reason, as in, because populations are growing, G and C plants, which yield more food, are needed. The opponent's claim, meanwhile, rests on the fact that these consequences are unknown, right? Maybe the crops have bad health effects, something like that. So these are our two claims, and now we know what we're looking for. It's either a strengthening of the first or a weakening of the second, or the best option, a comparison of the two, telling us that the first is a stronger claim. And this is exactly what statement E gives us. It explicitly tells us that the reason in support, a higher population which needs more food, is more important than the reason for opposing, whatever potential health problems may be. It's like two people are arguing, and when you're telling me that Richard is correct, you're also telling me that Anastasia is wrong, okay? So notice this was a precise answer. We formulated the description of the answer on our own, and then we went looking for it. And we didn't waste time reading the answers kind of naively and thinking, oh, that makes sense, it doesn't make sense. But we knew what we were looking for. And this is a much more efficient way of going through the answer choices. So the third key is the answers are confusing and time consuming. We should come up with our own answer before going over the answers and pay attention to every detail. Hopefully I explained why, and it's clear now. So just to recap our PAL system of the different tools you can use, precise is using just the given data, logical is using logic from outside, and alternative is when we have to, it's using the answers in verbal. Which brings us to our fourth key, one we haven't discussed yet, the alternative approach, spotting the irrelevant answers. So let's look at the question. Growing wheat in 500 to 200 BC in the region of Damchan required the use of large quantities of water for irrigation, which had to be brought from remote locations. And yet the Damchan people kept growing wheat, although they had the option to grow other less water-demanding crops, such as vegetables. Which of the following, if true, most helps to explain the Damchan's preference to grow wheat during the period of 500 to 200 BC? Okay, so here we're asked to identify a solution for a mysterious phenomenon. And this is a classic alternative question. Since it's not immediately obvious what the answer should be, it seems to make sense to just go to compare the answers. But let's do it. So A is irrelevant, since we're talking about 500, 200 BC, and this involves something that happens before 500 BC. Okay, so that doesn't help us. Remember, 500, 200 BC, in BC everything works the opposite. So this is 500, 200 before Christ. And before 500 BC could mean 600 BC, but it couldn't mean 300 to 400 BC. Anyway, A is out of our range and is thus uninteresting. So we can rule out answer choice A. Similarly, B is irrelevant because it describes something these days and not in the relevant era, which we're asked about, 500, 200 BC. C looks promising. Okay, it tells us that the reason that the farmers planted these crops. But wait, we are asked why the Damchan people in general made this choice. And the ruler is part of the people. Why did the ruler do this? We don't know. So C actually isn't our answer. D doesn't help us either. It describes other crops, and the fact that they weren't grown only makes the case of the wheat more mysterious. E, however, is what we're looking for. It's a legitimate reason for wheat to be grown. So that's our answer. And this demonstrates our fourth key. If we must use the answers, we should first summarize the given argument and compare small details with each answer. So, moving on to our fifth and final key. I hope you guys are excited. This is the happy face of boldface questions. So I know that it seems that there seem to be less and less boldface questions in the GMAT, but we still, until they're eliminated completely, we still want to discuss this. So if you feel like boldface is irrelevant for you, that's fine. But I still urge you to stick around because we have a gift at the end. Those of you here in the beginning already saw it, but if you join a minute late, you might have missed it. Anyway, so a lot of people are worried, I would say, about boldface questions, but actually they're not that hard if we get to know them. They always revolve around the same logic, which is the logic behind argument structure, and they ask the same question. What are the roles of the two bold-faced options? Okay, and they always have the same structure. Evidence plus assumptions leads to conclusion. So let's look at this question. So according to the latest census, the population of Oak City grew at an unprecedented rate last year, raising expectations for yet even greater growth this year. Factors that contribute to the increase in the number of city residents are either population growth or immigration, but the birth rate in Oak City has been declining steadily, and according to most recent estimations, the number of families immigrating to the city will be quite similar to that of previous years, probably contributing a comparable number of new residents. One may project with a considerable degree of certainty that Oak City will not accomplish its goal to surpass its previous record. All right, so obviously in boldface question we have a visual hint of what the bold-faced sections are and that they're bold, right? And the first thing we have to do is really read them carefully, paying attention to how the argument is built. So the whole first part of the argument, which I've just marked yellow, is facts. This is objective data straight from the latest census. Okay. The next sentence starts with the words but, and it presents a counterfact. Let's keep reading now. Estimations and also the word probably tell us that the first bold-faced portion is some kind of assessment, one which tells us of change which is expected to happen. One may project, okay, so the second portion is a projection. Let's go ahead and read this second portion. So this projection is directly based on the assessment which the second portion presented. If the number of residents won't grow, okay, Oak City will not break the record. Okay, so the first bold-faced portion is an assessment, and the second is a conclusion which derives from the entire argument. And that's the bottom line. This is exactly what answer choice A tells us. The first portion is an assessment which, if correct, would strengthen the main statement of the argument expressed in the second portion. So I hope that wasn't too fast for you guys, but all it goes to show is this final key, which is bold-faced questions always follow the same logic. Evidence plus assumptions lead to the conclusion. And this is pretty simple because, and it always repeats itself. A lot of people find bold-faced questions confusing because sometimes the order is mixed up. The conclusion comes at the beginning. There could be evidence and assumption for an alternative conclusion thrown in the middle. So what we have to do is seek out these three components, evidence, assumptions, and conclusion, and figure out what part the bold-faced sections play. So to recap, what all this part of the critical reasoning really goes to say is answer before reading the answers. This is the first and main commandment of critical reasoning questions. It's really the only way to solve all the questions in the time that we're given. And it's also a crucial way to avoid confusion and to zero in on what we're actually looking for. So that's it, guys. Those were our 10 keys, 5 data sufficiency keys and 5 critical reasoning keys. If you guys have any questions, hit me in the chat. And before I let you guys go, I want to remind you of our special offer, which I mentioned in the beginning, for the next 48 hours only as a token of our appreciation for being with us this hour. We have 30% off of all our GMAT courses, special Christmas sale. And it's only for the next 2 days. So if you want to take us up on that, go to examPAL.com and do so. And that's it, guys. I hope you found this helpful with at least one of these two tricky parts of the test, data sufficiency and critical reasoning. And I hope you take us up on it, on this offer, and I will see you on examPAL. If any of you have already been on the site, you know that we have a chat function in which you can ask questions and do so to check us, because you'll see we always answer, and that way I will answer you guys and be in touch with you yet again. So that's really it. I hope you guys have a good evening. I mentioned this in the beginning. You will have an option to get a recording of this and go over and kind of slow motion any part which I may have said too quickly. So so expect to get that in your mail. And if you guys have any questions, write them in the chat now, and I'll try and answer. But for now, I'm gonna. Otherwise, I will turn my mic off in just a second. Is there a code for 30% off? So no, you just have to go to examPAL.com, and it'll pop up. You'll see. Just go there, and the offer will pop up, and then you can use it. Helpful indeed. Thanks. Great. I'm happy it was helpful, and thank you guys for your time. Thank you guys for being with us this hour. Thank you for your time as well. Great. So thank you guys very much. I had a good time, at least. Hope you guys did as well. And see you guys in the